Okay, this is the review for the Level 3 assessment for carbon cycle and photosynthesis and respiration. In the first question, you're trying to interpret this graph and how it relates to the carbon cycle changes and also activities that may have caused those carbon cycle changes. So in general, what we see in this graph is that we are getting increase right here in fossil fuel emissions. The brown, the land use, isn't changing a lot. The green right here, the land absorption of carbon, is also increasing because that green section is getting bigger. The CO2 in the atmosphere is increasing. And then the CO2 in the atmosphere is also increasing. Okay, so the one thing that's not changing, as I said, is the land use. But basically everything else is increasing. And the reason for that is because we are burning our fossil fuels. Okay, as you can see up here at the top. Okay, because we're burning more fossil fuels, that's putting more carbon dioxide into the air. Again, this light blue area, which in turn is putting more CO2 into the ocean, this dark blue area, which in turn is causing plants and trees to have to take in more CO2, which is this green area. Okay, so the emissions or the releasing of the carbon has to be balanced by how much carbon is absorbed, or the sinks. Now we can apply some of the words that I asked you to use to these different changes. So the words are decomposition, photosynthesis, diffusion, and combustion. So combustion is related to this gray area here because combustion is the burning of fossil fuels. So we're seeing increasing combustion, which increases the amount of fossil fuels. The word photosynthesis is related to our green section there because the way that the land is absorbing more carbon, part of that has to do with photosynthesis, right? Because the trees on the land are using carbon dioxide or absorbing it. And then the word diffusion is related to the ocean data. Because there's more carbon in the atmosphere from the burning of fossil fuels, that means that more carbon will also diffuse into the ocean so that the oceans will be holding more carbon dioxide. And we actually see that happening. The oceans are becoming more acidic because they have more carbon dioxide in them than they ever had in the past. So there's 3 of our words. Now, decomposition, that's probably the trickiest one out of the 4. Decomposition is increasing because as humans we're creating more waste. Okay, more garbage. We raise animals for livestock and they create a lot of waste. We raise plants for food and that creates a lot of waste. So all of that fits into land use. And as I said, there's very little change in land use, that brown one, but there is a slight increase there. Okay, so because of using that land in different ways that's creating more composition, we're seeing a little bit of an increase in the CO2 released from decomposition. All right, so that's just answering number 1. Number 1 asks, how has the carbon cycle been altered over the years? We're seeing increased fossil fuels from combustion, increasing land absorption through photosynthesis, increased CO2 in the air because of combustion, and increased CO2 in the ocean through diffusion into the air, and then back into the ocean again. So the question then for number 2 is, what's going on the planet? What activities has led to those changes? So why do we see more combustion, for example? Okay, well, we see more combustion because combustion comes from things like cars and planes and general technology. And as we have more and more people on the planet that use more and more technology, and they're using fossil fuels to power that technology, that's why we get our increased combustion. And then remember that increased combustion then leads to more photosynthesis, more diffusion, more CO2 in the atmosphere. I kind of talked about the increasing waste already. Again, that has to do with more people on the planet, which we also produce our own waste products, but also through farming and livestock and things like that, we're increasing decomposition on the planet as well. So those are the types of activities, human activities, that are leading those changes in the carbon cycle. All right, the second standard about cellular respiration and photosynthesis gives you some data about colors of the bromothymol blue and how they relate to the actual presence or absence of the carbon dioxide. So this little paragraph or a sentence right down here at the bottom is really important. When carbon dioxide levels are high, BTB turns yellow. When carbon dioxides are low, BTB turns blue. Okay, so you have to pay attention to that in order to do this correctly. So I'm just going to go through and highlight the colors so we can keep track of them a little bit better. That is too big. We have to make it a little more narrow. Okay, so we've got yellow, and blue, and one green, which we'll just leave that for now. So again, carbon dioxide levels are low, we get blue. Carbon dioxide levels are high, we get yellow. All right, so we're going to take these one at a time and look at what's going on with the carbon dioxide based on the change. Are we using or releasing carbon dioxide? So let's start at the bottom. The first one, the snail in the dark, started yellow, ended yellow. Excuse me. We don't know that it's releasing, but for sure it's not using. Okay, it's not using carbon dioxide, because if it did use carbon dioxide, it would turn to blue, right? It started at a high yellow carbon dioxide level. If it used that carbon dioxide, it would go down to a blue low carbon dioxide level. The next one, the snail in the dark, started at a blue low carbon dioxide, ended in a high yellow carbon dioxide, so it's releasing. The next one, yellow to yellow, again, not using. Next one, blue to yellow, releasing. Release. So the next one is a little different. It's starting yellow and ending blue. So that means it's going from high carbon dioxide to low carbon dioxide, which means it's using CO2. The last one started blue, ended green. It's not all the way to yellow, but green is on the way to yellow, right? It's between yellow and green. So we also know it's decreasing the amount of CO2. So it's using CO2. All right, with that in mind, using and releasing, now let's go through what that means for photosynthesis and respiration. So I'm going to do that in a different color. Let's do that in red. So if any of these are using CO2 is photosynthesis. So these two are indicators of photosynthesis. Anything that's releasing CO2, those are indicators of respiration, right? Because photosynthesis uses carbon dioxide as a reactant. Respiration releases carbon dioxide as a product. Now we're ready to go through and answer some of the questions. Question 1. Plants perform photosynthesis. Well, right here is our photosynthesis, and do we have the plant doing it? Yes. The Elodea is the plant. So this statement is true. What data supports your conclusion? Like I said, these first two at the top, the Elodea in the light. And why does it support the conclusion? How do we relate this to photosynthesis? Because CO2 is being used. In other words, it's a reactant. Okay? Next one, number 2. Plants perform cellular respiration. Here, so we can see lots of examples in the plant section where the plants are actually releasing CO2 or at least not using CO2. So this first one that's very obvious is this Elodea in the dark. Right here. It's turning from blue to yellow, so it's releasing CO2. This one right here, the Elodea in the dark, stays yellow, which means it must be doing some respiration, because if it was only doing photosynthesis, it would turn to blue. It would use that carbon dioxide. And even this top one up here, where the changes from blue to green, right? It didn't go all the way to yellow because it's doing some photosynthesis, but it did change to green, which is part way to yellow, because it's also giving off some CO2. So plants are doing both photosynthesis and respiration in the light. In the dark, they're only doing respiration. So for number 2, the answer is true. The data that supports the conclusion, I just went over those 3 examples. And then the process of cellular respiration, CO2 is released. In other words, it's a product. Number 3, animals perform photosynthesis. Let's look at the snail, which is our animal. And we never see an example where CO2 or carbon is used by the snail, right? It never goes from yellow to blue. It's either released or definitely not using because it's staying at yellow. Okay, so this statement has to be false. All 4 of the snail examples support the conclusion because, again, we either changed from blue to yellow, showing carbon dioxide is being released, or it stayed yellow, proving that carbon dioxide is not being used. Photosynthesis, remember again, CO2 has to be used. So how does this apply? CO2 is not used by snails. Number 4, animals perform cellular respiration. Again, let's look at our 4 snail examples. In 2 of them, it goes from blue to yellow, showing that CO2 is released. That is definitely respiration. And even the ones that started yellow stayed yellow, meaning that the carbon dioxide is not being used. So there's the evidence, the color change for the snails. And then how does that process of respiration relate? CO2 is released. Again, that means it's a product in the equation.